All right, so now we're looking at gradient of a line. So now we're in syllabus topic 5.1, and we're looking at gradients. So the gradient of a line, in American English we tend to say slope, but those words are interchangeable. So the gradient is the change in the dependent variable divided by the change in the independent variable. So the dependent variable is always going to be y. So y depends on x. Our independent variable is x. So what we look at is the change in y over the change in x. So this Greek symbol delta means change. We find that change by doing y2 minus y1 over x2 minus x1. We also commonly refer to this as rise over run. More often, in everyday speech, we tend to talk about gradient quite frequently. Anytime you discuss a rate, you're talking about a gradient or a slope. So 50 kilometers per hour, how many kilometers I go depends on how many hours I drive. So kilometers per hour, 40 baht per kilo, a taxi charging 2 baht per 0.25 of a kilometer. All of those are different changes in rate, and so they're all gradient measures. If we think back to our last set of notes, we had that parallelogram. So I'm going to look at it again and find the gradient of each line. So looking at my points, negative 3, 4 is here, and then 5, 4 up here, 3, negative 1, 5, negative 1. So let's label them first. So we had A, B, C, D. And we know we have a parallelogram. So let's start with side AB. And let me put in all my lines here. Okay, so if I want to find this slope, so let's find this slope. We use the letter M for slope of AB. Well, I can see that I didn't rise at all. So if I just count that, I would say that my rise is 0 and my run is 1, 2, 3, all the way down to 8. So this slope, I could say, is a slope of 0. So this horizontal line has a 0 slope. Let's look at my other horizontal line. So looking at DC, this time I could use my formula. So I've got this point negative 5, negative 1, and 3, negative 1. So if I do y minus y, negative 1 minus negative 1, well, that's like saying negative 1 plus 1. Of course, that's going to make 0 on top. On the bottom, I've got negative 5 minus 3, that's negative 8. Of course, 0 divided by negative 8 is just 0. So our two parallel lines had the same slope. So we know that M of AB was equal to M of DC, and we also know that AB is parallel, we use this symbol for parallel, to DC. All right, let's look at our other lines. We've got AD, so slope of AD. First I'll do this one by counting. So I see my rise, I go up, so that's a little bit off. Let's try to put it directly above. So my rise, I go up 1, 2, 3, 4, 5, and then I go over 2. All right, so I could say that my slope is up 5 over 2. If I use the formula for BC, well, this point B is 5, 4, 3, negative 1, so I'm going to do y minus y. 4 minus negative 1 over, now I'm going to do my x minus x, so 5 minus 3, and I get the same thing, 5 over 2. So we're going to want to use our formula when it's hard to graph, but if it's easy to graph, I'm going to graph and look at my picture. I could have drawn my rise run this way as well, and I would find the same thing. That goes up 5 and over 2. So always rise over run or change in y over change in x to find our slope. And noting, of course, parallel lines have the same gradient.